So today I make a gigapixel panorama with a drone and with a tripod robot, and to align each arrow I use the compass, so we can align the first picture on north, and so we can at the end stitch together all these pictures. So it's not possible to take the sky with the drone. We have to do that with a tripod robot, like the Merlin Orion or another one. I use the same camera type, same CCD format and same lens as on the drone. As you can see, I use a Panasonic camera G7, same format as the X5 for DJI, and I use the same lens. With my own tripod PanoGear software I can make XML files and robot files to have the same overlapping as with the drone. So we have a full spherical panorama shooting. Here you can see my own PanoGear software, where I can simulate different cameras, different lenses, also the overlapping. I can simulate before I shoot. I developed this software for my own tripod gear robots, but I can use it for the Merlin Orion 2, and I can change nadir angle to simulate only sky shooting. I use the same algorithm in all my programs, and then I can start to take the shooting that's necessary to have the preset files for the Merlin Orion. So with this preset file I can then charge the program to the Merlin PanoGear, and it will take exactly the same shooting. As you can see here, that's the program. Maybe you already know the XML creator. So in the XML creator I have exactly the same algorithm. So we choose the 45mm lens, 20% overlapping, then we simulate. We change to spheric, and then we have exactly the same 183 images as I take in SplitPan. As I told you before, we cannot take 183 pictures with one battery, so I developed for this reason the SplitPan app, where we can split a panorama in two missions. The SplitPan app calculates for each lens the two mission code. So for instance, the 45mm takes 4 rows in the first shooting with 84 images. First we start with aircraft RAW, and then we change to gimbal yaw. The advantage of the gimbal yaw is that it's very precise, and even under windy conditions we can have precise shooting. In the app we can always see aircraft yaw, gimbal yaw relative, to see what's happening with the shooting. So I will a little bit speed up the rest of the first shooting. You can see each image. For the first shooting the coordinates will be saved, and we use them later in a waypoint mission for the second shooting. At the end of the mission we reset the gimbal to 0. The second shooting takes 99 images, only with gimbal yaw, and we see here the waypoint mission. So the aircraft flies to the first position, and the heading will be resetted to 0 degree north. The maximum distance between the aircraft and the first position has to be less than 200 meters. That's a security that I built in the app. So the drone flies to the coordinates and also to the same altitude from the first shooting. So we speed up a little bit this section. You can see the 99 images. We can always check aircraft yaw, gimbal yaw relative to see what happens. Timeline mission code needs fast hardware. Personally, I use an iPhone 8 Plus. I recognize that the signal has to be strong and also the hardware has to be fast for timeline missions. At the end of the shooting, the gimbal will be resetted to the first position. Let's go to the stitching part. I use Autopano Giga, more than 100 images. So first I load the XML file, then all the pictures, 239 pictures. As I aligned the two shooting methods with the compass, we are perfectly in line if we have a look on these images. I use a 64 GB RAM self-built computer to stitch large images like that. Needs quite fast hardware. So let's have a look. We have an RMS from 2.96. That's quite a good result. But I recognize that it's easier with these lenses to stitch together images as with wide-angle lenses. You have to save the image in the TIFF format. It takes about 5 GB, this one. So in Photoshop 2018 there is no longer limitation of 2 GB. I use Panotour to publish the panorama. Only HTML5 export. And this large image has more than 11,000 tiles. I hope you enjoyed this video. Until the next time, thank you for watching.